This video is about functions of a function, and to do that we're going to look at question 4 part B. But let's start by reminding ourselves of the standard integrals. I don't expect you to be able to derive these, but I do expect you to know them. So let's do part 1 just as a quick refresher. We want to do the differentiation of secant of x. So let's look at the standard integrals. Secant of x is there. It's equal to secant x times tangent x. Now we get on to part B. We're going to differentiate log x secant x. Log x is a function, secant x is a function, so this is called a function of a function. So how are we going to differentiate that? Well, let's look at the standard tables. We'll start with the log. Differentiation of log of x is 1 over x. So in this case it's what's in the bracket, so it's 1 over secant x. And then we differentiate secant x, which you can see here is secant x times tangent x. Obviously that secant and that secant can cancel, which gives us the answer of tangent x. Part 2. This time we're going to differentiate the log of sine x. Well, this should be fairly straightforward now. First of all, we'll differentiate what's inside the brackets, so that's 1 over sine x, and the differential of sine x is cos x. So cos x over sine x, we know that sine x over cos x is tangent, so cos x over sine x must be cotangent, and that's the answer to part 2. Part 3, we're going to differentiate the log of secant x plus tangent x. As before, we'll end up with 1 over secant x times tangent x, and now notice this is a plus here, so we differentiate these two terms one after the other. So the differential of secant, as we can see there, is secant times tangent, and the differential of tangent is secant squared. Let's take a secant out of the bracket here, so we get secant outside of tan x plus secant x. There's a tan, there's a tan, there's a secant, so they can cancel, giving us the answer of secant x. And that's the end of part 3. So now you know how to differentiate functions of a function.